Okay, this lesson is the second part in a two-part lesson on Newton's first and second law. So first of all, for the content, in this lesson, we're going to talk about some of the common mistake that's is common in Newton's first law, and the second one is to talk about how to apply Newton's second law effectively in questions related to the second law. So let's look at the questions that usually students have a common mistake. Alright, so in this case, a 5 kg object is being pulled by a 10 Newton force to the right on a frictionless table. After some time, the block enters a region that is rough and experiences a frictional force of 10 Newton. So the question is, what is the subsequent motion of the block in this rough region? So in this first point, in this first place, there is only one force acting on the 5 kg block. Obviously, the block will accelerate because there's resultant force. Now, in the second part, when the block goes into the rough region, there is no resultant force because the two forces are equal and opposite. So the question is, the options, is will the object come to a slow down to a stop, or will the object stop immediately, or will it move at a constant speed in a straight line? Okay, I would like you to pause the video at this point in time and to restart the video once you have already find out your answer. So what's your answer? So the actual answer is 3. Why is it so? Why is it moving at a constant speed in a straight line? So let me explain using the next slide. So first of all, when it's moving in this region, okay, there will be no resultant force because the two forces are balanced and opposite, so there's no resultant force. And because there's no resultant force, the object will either be at rest or move at a constant speed. But as you know, that the object will choose to move at a constant speed in a straight line. And why is it so? Because just before it enters the region, okay, at this point, okay, I hope you can see. At this point, just before it enters the region, alright, the object has some speed, and this speed cannot just disappear. Alright, the object will tend to stay in its motion, and since it already has some motion, it will tend to stay in this motion. So because there is some velocity just before it enters the rough region, okay, you expect that this velocity will be the constant velocity that the block travels in the rough region. So because there is some velocity, okay, the final velocity that the object will experience and how you will move in this rough region will be this constant velocity for the whole journey, or constant speed in the straight line. Alright, so that's the explanation. Now, this is also the reason why we observe a lot of things every day in our life, but we do not know that actually this is Newton's first law taking place. Alright, a car that can reach maximum velocity on the road is actually Newton's first law kicking in, or a parachutist falling at terminal velocity when he's skydiving. Alright, so if you look at these two animations, the one on the left shows that initially the thrust of the car is 1000 and there is no speed initially. Alright, so then as the speed increases, the resistance increases until a point where the resistance is the same as the thrust. When this point is achieved, alright, there is no resultant force and the object or the car reaches maximum speed. In the same way, the parachutist initially when it falls out, okay, there's only the weight acting on it and there is no speed. Okay, then as it falls faster, the speed increases and the air resistance increases. The air resistance will increase to the point where it equals to the weight. When it equals to the weight, it reaches terminal velocity and the parachutist will fall at a constant terminal velocity. As you know, terminal velocity actually also means constant velocity, but a very high constant velocity. Alright, so let's move on. So let's look at Newton's second law. As we know that Newton's second law is a law of resultant forces, so how do we exactly find resultant force? Okay, there are actually two methods. The first method is to add or subtract all the forces that is in the object. So for example, if you're given this kind of question where the forces are acting on the object, obviously you can add and subtract the forces, and the result is just one single force that represents these forces. All right. Another way to find the resultant force is if you are given the acceleration, you can use the formula F net equal to ma, which is resultant force equal to mass times acceleration. So if you are given the same object of mass 2 kg and an acceleration of 1.5 meter per second square, the resultant force can be found by multiplying the mass and the acceleration, which will give you the same effect. In fact, these two questions are exactly the same question, but the information given are different. The first one, the information given are the forces, so you need to use add and subtract of the forces. In the second case, the information given is the acceleration, so you need to use F net equal to ma. So in the next 3 slides, we're going to deal with different questions on how to find the acceleration, or how to find the mass, and how to find the force, okay, of the object. All right. So in this first case is to find the acceleration. So as we know, there are actually 2 ways to find resultant force. So in this case, obviously the easiest way to find resultant force is to use F net, use the adding and subtracting of forces. So I'll write down the resultant force as F net will be 15 plus 5, which is 20 Newton. And then we also know that after you found this 20 Newton, the other way to solve for resultant force is F net is equal to ma, which is 5 times the unknown acceleration. So if you lay down these 2 methods clearly, you realize that you arrive at 2 equations, and they are both equal to each other. So first equation is equal to second equation, so we can simply say that phi a is equal to 20. So your a will be equal to 4 meter per second square. All right. So let's try the second question. I would like you to pause the video and then you try it first before we start. Okay, have you solved? So I need to create some space, so I'm going to erase the first part and then I will start again. So these 2 forces cancel out, all right? And then these 2 forces cancel to give you 1 Newton. So that means that actually is 4 Newton to the left. So your F net is going to be 4 Newton to the left, all right? And then the other F net will be using ma. Is going to be careful, this is in grams, so you need to convert to kg times your a. So equating these 2 together, you get 0.8. A is equal to 4. So what is your a? So so your a will be 5 meter per second square, right? Okay, so let us try another 2 questions. In this case, these 2 questions will be finding another unknown. Sorry, this information is wrong. Is to find the F1, right, in these 2 questions. All right, so in this case, what are you given? You're given the acceleration. So the most convenient way is to find the F net using the ma formula first. So instead of using the resolving of forces, I'll use F net equal ma. So it'll be 2 times 3, which gives you 6 Newton. Alright, so after you found this, you also know that F net is also equal to the sum of the forces. Now, you can use f1 minus 8 or 8 minus f1. But why do I use 8 minus f1? The reason why I have to use 8 minus f1 is because the resultant force have to be pointing in this direction, as the resultant force will be in the direction of the acceleration. As such, 8 will be bigger than f1 in order the resultant force is pointing in this direction. So you have to put the 8 in front. Alright, so then you realize again you come with these two expressions which are equal to each other. So 8 minus f1 will be equal to 6. So f1 will be equal to 2 Newton. Alright, so let's move on to the last question of this part. So how do you solve for this? You can pause the video again. Okay, so now I expect that you have already solved this and you have restarted the video, trying to save space and leave this here. So again, you can use F net equal ma to find the first expression. So you're going to get 0.5, be careful, this is in kg, times 10, which gives you 5 Newton. Alright, so the other expression will be F net is equal to, again, do you use the right or left? You use the right because the resultant force had to be in the direction of the acceleration. So you will put 3 plus 2 minus F1. So basically it will be 5 minus F1 equal to 5. So your F1 is simply 0 Newton. Alright, there is no value for F1. So last one, again there's a mistake here, is to find the mass m. Alright, the mass m. So I will try to find the first question, and the second one you will have to try again. So in this case, I will use F net equal ma again as the first expression. So it will be 2.5 m because m is the unknown, and the second expression will be F net equal to 15 minus 5. Why is it 15 minus 5? Because 15 is in the direction of the resultant force, as the resultant force has to be in the direction of A. So you get 10 Newton. So 2.5 m is equal to 10. So m will be equal to, I need to use some max here. So it's 4 kg. Right, so no issue. So now I want you to pause the video and then try the next question. So have you finished? Okay, let's discuss together. F net will be equal to 4m, and the next F net will also be equal to 8 plus 2 minus 2, because again 8 is in the direction of the resultant force, so we get 8 Newton. So this is an easy one. 4m will be equal to 8, so m will be equal to 2 kg. Alright, so I hope that you're able to solve all the questions that's presented here, and you understand how to use the expression of resultant force to find the answers for different questions, whether it's to find F, M or A. Okay, so that's all for this lesson. Thank you and have a nice day.